Well, welcome back, everybody. This is chapter 6.5 or 6-5 on the quadratic formula and the discriminant. It's sort of the culmination of all the methods in this chapter 6 for solving quadratics. And I just quickly want to review for you that there were 5 ways to solve a quadratic. Also, remember that solving a quadratic is finding the x-intercepts. Those are called x-intercepts. They're called roots. They're called zeros. They're called solutions. And so when we use the word solve the quadratic, they're meaning find the solutions, which are these 2 points. There are 4 different names. They all mean the same thing. And in addition to those 4 names, there are 4 methods for finding those 2 points. And sometimes there's not 2 points, but those 5 methods are solved by graphing. And that particular technique takes a long time to do. This is a time-consuming technique, and it also is not always that easy to get real accurate with it. Number 2, solve by factoring. We just did that in the last assignment, I believe. Solve by factoring. And this is a good technique when it's easy. When the factoring is easy. If the factoring is not easy, then this technique would be too hard to do. But when the factoring is easy to do, that's a great technique. Number 3, solve by the square root property. And I'm going to review that again today before you go into this assignment. Solve by the square root property. And this is good to use when the b value of the quadratic is 0, or in other words, there's no b term. So great to use that. Technique number 4, we are going to skip it. It's called solving by completing the square, and we're going to skip this. It's in your book. If you are interested in knowing how to do this, you can complete the square if you want, but we're not going to tackle it. It's too time consuming, and it's easy to goof up on that. And so that brings us to number 5, and that is solve using the quadratic formula. The quadratic formula. Some of you may have seen this formula before. The quadratic formula is the fail-safe. It's that technique that you can use. If you can't use anything else, you can always use the quadratic formula. We're going to call it a fail-safe because we can always use it. And sometimes it takes longer than these other techniques up here. So since we're interested in time, you're going to want to pick one, probably 2, 3, or 5. Probably not number 1, and we're not going to use number 4. But you're going to try to pick techniques 2, 3, or 5 here to solve these. And on tonight's assignment, you will have your choice. You'll have the choice of picking whichever technique you want. So we're going to do 2 things tonight. Number 1 is you're going to solve using the quadratic formula, this one, and then you're also going to pick the best technique. Pick the best technique on this assignment tonight, okay? And we'll go over those again as we do some problems here. So let's start by talking about what is the quadratic formula. All right, let's take a look at what the quadratic formula is. The quadratic formula always starts out with x equals, and then there's a formula here. And the reason it's x equals is because it gives us the x value of an ordered pair. To find the y value, we'll plug the x in, and then we can find the y value. But the quadratic formula helps us find the x value of an ordered pair for where the graph crosses the x-axis. So that's going to be the x value right there. And then you'll have another ordered pair that will give you the other ordered pair will be x. So there's going to be 2 answers for some of these, not all of them, but there's going to be 2 answers. So we're trying to find the x crossings, the x-intercepts, the zeros, the roots, the solutions, by using this new formula. Well, what is it? You're going to need to memorize this, so I'm going to write it out here. You're going to have to try to commit it to memory. Here it is, negative b. Well, maybe we should start by reminding you that the equation of a quadratic is ax squared plus bx plus c. So if we had numbers in here for a, b, and c, we'll do that in a second. We can go ahead and use this formula. Here it is. Negative b plus or minus, that means there's two answers, the square root of b squared minus 4 times a times c all over 2 times a. Now you'll have to memorize this, okay? This parentheses, this line that goes across here is a parentheses, so when you enter this in the calculator, don't forget to put this in parentheses, and don't forget to put this in parentheses if you enter something in the calculator. But we're going to be solving the problems not just with the calculator, but we're going to ask you to leave them in simplest radical form. So your answers are going to be presented in two ways. In simplest radical form, and then sometimes you're going to be asked to use the calculator and to round if necessary. Okay, you may not have to round them, but you're going to have to put the answers in simplest radical form and then using a calculator as well. So let's take this formula now and try a problem, show you how it works. We're going to start with a nice simple problem here, and I'm going to move to the next page to do that. Alright, here's an equation we're going to use this quadratic formula on. Now, as I look at this problem, I'm guessing that this probably factors to 14 and 2. And so if I were going to do this problem, I probably would factor it, but our instructions on this problem are to use the quadratic formula. So to use the quadratic formula, remember, we're trying to find out when y is 0, what is x? What is x? So in order to do that, we're going to set this equal to 0, and I'm going to move that 28 over to the left and set it equal to 0. So when it's equal to 0, that means that the y value is now 0. And we're going to see if we can come up with the x value. Okay? I can see that this would factor, but we're going to use the formula anyway just for the practice here. Alright, here we go. Negative b. Well, that'd be a negative 12. So I'm going to go negative 12. A double negative there gives me positive. Plus or minus the square root of b squared. Now I could show that here. I could go negative 12 squared, but sometimes it's just easier to do the arithmetic on some of these in my head. B squared, oh, that's negative 12 squared. Well, what is negative 12 squared? Negative is positive, so this is 144. Sometimes it's just quicker to do a little bit of arithmetic in your head. B squared minus 4, and this is times a, and I'm going to put a in parentheses here. A is 1, it's right here, and c is negative 28. Notice I'm putting a and c in parentheses here. They're going to get multiplied times 4. All over 2 times a. In this case, a was 1. So there it is. Now it's a matter of just kind of doing the arithmetic here. And if you use your calculator, it might just be more work than necessary. All right. I usually start when I solve these right here dealing with 4ac. Okay. Negative 4 times 1, of course, is negative 4. So negative 4 times negative 28, well, let's see, 28 times 4, carry that's 32, 152. Okay, so this is all a positive 152. So I'm just going to bring this all down. 144 plus 152. How did I get positive? Negative times negative is a positive 152. All over 2 times a, which is 2. Okay? Now we got some more arithmetic to do here to finish this out. I may have to go up to the top or over to the side to do this. This is 12 plus or minus the square root of 296. 296 296 all over 2. Well, 296, I'm sorry, that's not 296. I must have made a math error here. Let me see. Oh yeah, 4 times 28 is 32. Oh, it's 112. I don't know where I got 152. 112, so that's 112. Now that means 144 and 112 is 256. Okay, there it is. Okay. Now, as I look at this, I realize that 256 is a perfect square. So we're going to go over to the side over here. Move that up a little bit. This is 12 plus or minus the square root of 256 happens to be 16 all over 2. So what is this? Well, there's 2 answers here. And if we go around to the top, we got 12 plus 16 is 28. 12 plus 16 is 28 divided by 2. One of the answers is 14. And then 12 minus 16, I'm going this way now. 12 minus 16 is a negative 4. Negative 4 over 2 is a negative 2. And there are my 2 zeros right there. And you know, I kind of saw that up at the top that I was going to factor that to 4 and negative 2, 14 and negative 14 and positive 2. But there are my 2 zeros. So what we found is that one of the zeros is at 14 and the other one is at negative 2. Now this took quite a bit of work, and if I was to factor this, I think I probably could have done it faster. But this is the practice that we're going to need to do tonight, is practice some of these quadratics. Let's do another one here. All right, let's do this one. I can see also that this would factor fairly easy, but we're going to use the quadratic formula. So here we go. I think I'll write a little smaller this time. X equals negative b. Well, that'd be a negative 22. Negative 22 is b. Negative b plus or minus the square root of b squared. Well, 22 squared happens to be, what, 400 and something? What's 22 squared? Let's find out. That's 484. This is 484. Okay. Minus 4 times a is 1, and c is 121. Okay. All over 2 times a. So there you go. B squared happens to be 484. And now let's do the arithmetic again. Well, 4 times 121, I can tell what that is. That happens to be 484 also. 484 minus 484. Oh, that's going to work out really slick here. All over 2. So it's negative 22 plus or minus the square root of 0 over 2. Now, a couple things we need to note. First of all, that this under the radical here is 0. And the square root of 0 is just 0. There's no such thing as a positive 0 and a negative 0. So in reality, we're only going to get one answer here because a positive 0 and a negative 0 are the same thing. So our answer here is going to be a negative 22 all over 2, which is a negative 11. Now, remember we said that the quadratics usually have two roots. Well, they don't always. Sometimes one of the roots is what we call the double root, and that's what's happening in this case. Double roots, let's go over here, go out to a negative 11. This square root actually sits on the vertex right here at a negative 11. And it's a double root. Anytime a root sits or hangs from the x-axis, it's a double root. Okay? And so negative 11 happens to be twice. And double roots only appear on the graph once, but there are really 2 of them. Like plus or minus, but you know, there's really only one root there. So this problem is illustrating the fact that when there's a 0 here, you're only going to get one double root. One root, one answer, one ordered pair, negative 11, 0. There's your answer. It happens to be what we call the double root. Let's do another one. All right, let's take a look at this one. Have you memorized the formula yet? Keep working on it. Need to have that memorized. All right. This is already set equal to 0, so we're going to find the roots, the zeros, the x-intercepts, the solutions, and we're going to use the same formula here. So here we go. Remember, this is A, B, and C. X equals negative B, that'd be a negative 4, plus or minus the square root, B squared, 4 squared is 16, minus 4 times A, which is 2, times C, which is a negative 5. All over 2 times A. Okay, 2 times 2. Well, let's see what we get here. Negative 4 plus or minus the square root of 16. This is negative 4 times 2 is a negative 8 times a negative 5 is a positive 40. Positive 40? That's 10 and 4 is 40. Yeah, negative times negative is a positive 40 all over 4. 2 times 2. Or negative 4 plus or minus the square root of 56 all over 4. Now you can see here that we're going to end up with an answer that does not have a rational number because this is not a perfect square. Now I can simplify this. Let's see. 56 has a perfect square factor in there. That would have the square factor of 4 times 14, I think. 4 is a perfect square factor. And so I'm going to have to move up here now. So I end up with negative 4 plus or minus the square root of 4 is 2 root 14 all over 4. So this is our answer, except we actually can reduce each of these terms by 4 here, or by 2. So negative 2 plus or minus 1 root 14 all over 2. And there's our final answer. This number is what you call an irrational solution. And there's two answers here. We could actually use the calculator to calculate both of these. Let's go ahead and do that. All right. All right. I've entered something in the calculator here. And some of you will notice right off the bat that this is actually entered incorrectly, because our problem was negative 2 plus or minus the square root of 14 all over 2. So I should have put this first part in parentheses, right? So it's actually entered wrong. So let's go back here and put the first part in parentheses. I'm going to use my second insert feature here. Put a parentheses there, put another one right here, second insert. There you go. Now I have the numerator in parentheses. Remember, this line acts like a parentheses. If you don't have that line there, it will be wrong. Let's see what we get for an answer. All right, the answer is 0.8708. I'm going to jot that down here on my board, 0.8708. Now you'll notice that that's only one of the two answers. If we look back at what we had originally, it was plus or minus. So I'm going to go up here and I'm going to change this original problem and put a minus sign in there. Let's get this off the screen here now. Let's put a minus sign in there, and I'm going to do that by hitting second entry, and it made the equation live again. And I'm going to go over here and replace the plus sign with a subtraction sign. There's my second answer. There's a plus or minus. So here's plus or minus root 14. And my answer is negative 2.8708. Negative 2.8708. So you see there's two answers here, and they're not necessarily opposites of each other. So you can use your calculator when they ask you to give a decimal value, particularly with an irrational number. But we've left the answer here in what they call simplest radical form. This is in simplest radical form, and this is in a rounded decimal. Now, let me ask you this. Which one is that more accurate? Yeah, this is more accurate because it's not been rounded. This decimal, we have rounded it to be able to write it down. This is a more accurate answer. The decimal is really an approximation. So if it asks for an exact answer, this is exact. And this one is approximate. Just make a note of that when you're doing these problems. That simplest radical form is really more accurate. Let's take a look at another one here. All right, let's take a look at this one. I need to first of all set it equal to 0, so let's move the negative 13 over to the left. Becomes a positive 13 equals 0. Now we're going to use the quadratic formula. Here we go. X equals, got to start with x equals. Negative b. Well, b is negative 4, so a negative negative 4. By the way, I have a habit of, if I've got a double negative, of putting a plus sign here, so that reminds me that I actually did a double negative here. Negative negative b, a negative b, okay, plus or minus the square root of b squared. Well, b is a negative 4, and I square that, I get 16, minus 4 times a, which is 1, times c, which is 13. By the way, I'm still using parentheses here. I recommend you do that. All over 2 times a, and a is 1. 2 times a. All right? Well, let's see what we got. We got 4 plus or minus the square root of 16, and this is minus 52, all over 2. Now what you see happening here now is that we've got a negative under the radical. This is 4 plus or minus the square root of a negative 36 all over 2. Now, does this ring a bell with what we're going to do? Well, if you remember back in the last chapter, we had to deal with negative radicals, radical that's negative underneath. And so what I've got here is the 4 plus or minus the square root of negative 1 times 36. Negative 1 times 36 all over 2. Well, we know the square root of 36 is 6, and we know that now that the square root of negative 1 is I. So I've got 4 plus or minus 6i all over 2. 36 times a negative 1, that's 6i when I take the square root of it. So there's an answer, although actually I can reduce this. I can reduce all the terms here by 2. So 2 plus or minus 3i all over 1. Okay, so there's our answer. You'll notice that our answer is a compound number. Okay, from the complex number system. Complex number system, and it's a real part and an imaginary part, and there's 2 parts to it here. Okay, and there's 2 answers. So what this is saying, this is not a real number. What this is telling us, and I'm going to erase this real quick here, is that this graph that we've just made here, this one had a y-intercept of 13, and I'm not sure exactly which side it's on, but we know that this parabola opened up because it was positive and it had a y-intercept of 13. But you'll notice that it never ever crossed the x-axis, because if it crosses the x-axis, then it has real roots. But this does not have real roots. This has complex roots, imaginary roots. And what we find that is some parabolas don't have a real answer. And that's the case here, where it has 2 roots, but they're not real. They are imaginary roots. So this is going to happen, and this is the topic that we need to talk about for the next 10 minutes or so. Okay? All right, we need to talk about 3 things, 3 types of problems that are going to occur. One of those problems is where you have 2 roots, like this. One of those problems is where you have 1 root, and the parabola sits on it, or it could hang from it, might hang from it instead of sitting on it. And you'll have another situation where there's no real roots, like we just saw. There are no real roots. There's one real root, and over here there are two real roots. And we can predict when this is going to happen by looking at this thing under the radical. This is found on page 316 in your book, page 316. I'm going to go over this thing. This thing under the radical, b squared minus 4ac, is going to be our tip. It's going to show us something. This is called the discriminant. Discriminant. Not the determinant. We had that back when we were dealing with matrices. This is called the discriminant. b squared minus 4ac. Now, I don't know if you remember, but when we did all of these problems, on the first situation, when the discriminant was positive, this thing under the radical was positive, we got two roots. When the discriminant was negative, the thing under the radical was negative, we got no real roots. It didn't cross the x-axis. And that one situation we got, when the discriminant was 0, the thing under the radical, we only had one real root. This is a way you can tell by looking at a problem how many roots it's going to have, and are they real or are they complex. This has no real roots. It has two complex roots, but no real roots. I can write that down here. It has two complex roots. Okay? Now, you'll need to study this a little bit on page 316, but let's practice this a little bit here, okay? All right, let's start with this problem. We're not interested right now in exactly where the roots are, but I want you to be able to tell, are there two real roots, one real root, or no real roots? Remember, this is when the discriminant is positive, this is when the discriminant is negative, and this is when the discriminant is 0. So here we go. B squared, what we're looking at is b squared minus 4ac. Well, what is it? B squared, negative 12 squared. That's 144 minus 4 times a, which is 9, times c, which is 4. I got 144 minus 16 times 9. Well, what is 16 times 9? 16 times 9 is also 144. So 144 minus 144 is 0. Oh, that tells me if the discriminant is 0, that means that it's got to be this situation here. Because it's got one real root, and that parabola is going to sit on the x-axis, right on its vertex, or it may hang from it. Okay, let's take on another one here. All right, let's take this one and find out which of these three situations we're in. We're not interested right now in where the roots are, but whether there's two real, one real, or no real roots. Here we go. We're going b squared minus 4ac. Remember, it's the thing under the radical. B squared. Well, let's see. 16 squared minus 4 times a times c. All right, let's see here. 16 squared is 256 minus, this is 66 times 4, 264. 256 minus 264, oh, that's a negative number, negative 8. Oh, yeah. So the thing under the radical is negative. You can't take the square root of a radical and have a real number. So that's got to be this situation, where the radical, the thing under the radical is negative. So this has no real roots. They're complex roots involving I. You know, something like 2 plus 3i or something like that. Let's look at another situation. All right, let's do this one. B squared minus 4 times a times c. So AB is 8. 8 squared is 64 minus 4 times A is a negative 5, and C is a negative 1. 64 minus is a negative, minus 20 gives me a positive 44. Now right now I don't care so much that it's 44, I care that this is a positive. So that tells me it's got to be this situation. When the discriminant is positive, it's got 2 real roots. So I want you to go back and look at this whole section on page 316 and make sure you understand how you can tell when something is the discriminant. All right, let's do one last thing here today. Okay? All right, on page 317, you will see the 5 methods that I discussed earlier. And remember, we're going to throw out the one that says completing the square. Don't worry about that one. Just draw a number through that one. And you're going to pick a method on some of these problems. It's going to say pick the method that you think is going to be the best. So of the other remaining 4 methods, I want to talk to you a little bit about something called the square root property. When you get a problem that you can use the square root property, let me show you how you know that's going to happen. Let's take a look at number 8. Okay, x squared plus 8x equals 0. Now I could solve this problem several different ways, but I could use the square root property to solve this as well, couldn't I? No, let's not do this one. Let's do a different one here. All right, let's take on number 32 instead. Now I could factor this. I could use the quadratic formula. I could graph it. But when there's no b term, and notice that this is A and this is C, and there's no b term in the problem. When there's no b term in the problem, the square root property is a good way to go. Instead of setting it equal to 0 in order to factor it, let's get x alone. Well, what am I going to do? I'm going to add 8 to both sides. Divide by 4. X squared is 2. And now you can take the square root of both sides. Square root of x squared is x, and the answer here is plus or minus the square root of 2. So the square root property, you use it when there is no b term. When there's no b term, you're going to use the square root property. So if you see a problem where there's no b term, the square root property works really great. All right, I put up here, page 317, 5 different methods you can use to solve quadratic equations. And remember, we're skipping this one, completing the square. But it tells you when it can be used and tells you when the best time to use it is. Read through this. Make sure you understand this. Square root property works really great when there's no b term. Okay, and then you could factor. Graphing is sometimes possible, but it's usually it takes a little bit more work to solve that one. And the quadratic formula can always be used when other methods fail or are too tedious, take too much work. So let's take a look at some of the problems that you're going to be doing. I don't want to focus right now on the ones where you have to use the quadratic formula. I want to focus on the problems where you get your choice. Okay? Okay, I'm on page 518, or excuse me, 318, and there's some problems at the top here. It says solve each equation using the method of your choice. And it says find exact solutions, and that means don't use your calculator. Leave your answer in simplest radical form. Now as we look at these 4 up here, let's see if we can determine how hard they are going to be to do different methods. Number 8, for example. As I look at number 8, this would be very easy to factor an x out, and I'd get x plus 8. This one is factorable and real easy to do that with. So I would use number 8. I would just factor that. Number 9. Well, you know what? That looks like that's a trinomial that factors to x plus 2 and x plus 3. So I would factor that one as well. Number 10. I don't see that this one's going to factor. In fact, I don't see that a factor. So I would probably use the quadratic formula on this one. And this one over here, we got to add 2 to both sides here, and we'll get 4x squared plus 20x plus 27. Those are big numbers, and this one may not be very factorable. So I'd probably use the quadratic formula on that one as well. So as you look on the problems below, the same thing. Let's go down to problems 28 and below. Down here, okay? All right, starting at problem 28, again, you get your choice of how you want to solve these. You know, when I look at some of these, like 34, for example, that one would be pretty easy if you divided both sides by -4 and then took the square root of both sides. Because if you divide both sides by a -4, you'll get -7 over here. And then take the square root of both sides, you're going to get an imaginary number because you're going to have the square root of a negative. So this one's going to be complex numbers, and you could use the quadratic formula, but you'd have to expand this first to do that. You'd have to expand the polynomial, the binomial, and then multiply by -4 or whatever. It would be easier probably just to go ahead and solve this by the square root property. How about number 29? I would probably solve that by the square root property. Just subtract 3 from both sides, and then you divide both sides by 7, and you get the square root of that. Okay. A problem like number 36, on the other hand, looks like it's probably factorable. If I move 8x over here, I might have 2 factors that might solve and give us maybe not. And once you get into it and you decide the factoring is too tedious and it's not working, it's too hard, abandon your other technique and just go and use quadratic formula. It works great if you use the quadratic formula. So tackle these problems tonight. You're going to work through 39, the odd ones tonight. You can check your answers in the back of the book. They may or may not tell you what the best method is to use there in the back of your book, but you pick a method that looks like it's going to be the least amount of trouble. So I'm going to come back and do some more problems for you on the next assignment. It's on the same page, but the even ones, I'm going to do a few with you and the story problems to boot. So here's your homework for tonight. All right, so here's your homework for this part. This is the first part of section 6-5, part 1. This is the first part of it, and I will do some more problems for you on the next assignment. So work hard on this stuff. It's pretty important, especially in advanced algebra, in pre-calculus and beyond. So enjoy.